Welcome back to the Savage Sullivan Math website. Today we have a special treat for you. Today Mrs. Savage and I are going to show you the exact same problem worked through in two different ways. So we have two radical terms being multiplied together. So remember, between the 2 and the radical 6, and then as well as the 4 and the radical 8, that's considered multiplication. So you could break it up this way and just show that multiplication. And due to the commutative property of multiplication, doesn't matter what order you multiply in, we can rearrange these terms so they look a little bit better to us. We know what 2 times 4 is. 2 times 4 is 8. So now we have this 8 times radical 6 times radical 8. We are going to break down these individual radicals, and we are going to look at their products all together. So radical 6 breaks down into radical 2 and a radical 3. Radical 8 breaks down into a radical 2 and a radical 4. Aha, perfect square right there. The square root of 4 is 2. So that's going to be on the outside. So, okay, I'm going to rewrite the problem now because it's looking a little confusing. I've got the 8 out front, now I have this 2 out front, and then I have all of these radicals. I've got the square root of 2, another one, and then a radical 3. Okay, I'm looking for any pairs that I can change to squares. Got a pair to square right here. And remember, the square root of 2 times the square root of 2 is just a plain old 2. So I've got 8 times 2 times 2. Don't forget about the radical 3. So 8 times 2 is 16. 16 times 2 is 32. Final answer is 32 radical 3.
Wow, Mrs. Sullivan, that was really exceptional. The cool thing about algebra is that there's often more than one way to tackle a problem. So Mrs. Sullivan simplified the radicals and then multiplied out in the end. Here, we're going to multiply first and then simplify, and if we did it correctly, we should still arrive at the same answer that Mrs. Sullivan did. So when I look at 2 radical 6 times 4 radical 8, I'm actually going to go ahead and just multiply out first. So when I look at this, I have my 2 coefficients, 2 times 4. So I'm going to go ahead and I'm going to multiply those together. And I'm going to do 2 times 4 and get 8. Then I'm going to move to my radicals, and I'm going to say radical 6 times radical 8, and I'm going to get radical 48. Then it's just like our other video where you have a single term radical with a coefficient on the outside. So now I'm going to break down that radical 48. So I'm going to ask myself, what is the biggest perfect square that goes into 48? I believe it's 16. So we're going to do radical 16 times radical 3. But don't forget, this 8 has to come along for the ride, so it's going to attach right onto that radical 16. So then when we look at this, we're going to ask ourselves, what can I simplify? Well, we all know what the square root of 16 is. That's just a plain old 4. That 8, again, is attached to it by multiplication. Remembering in algebra, 2 things stuck together means multiplication. And I'm going to look at radical 3. Are there any perfect square factors other than 1 that go into 3? Nope. So that stays radical 3. And now all I have to do is multiply the 8 and the 4. 8 times 4 is in fact 32 radical 3. Wow, we got the same thing Mrs. Sullivan did, but doing it a different way. Either way you pick is totally fine. If you found this video helpful, please like and subscribe.